for the protection or the preservation of the food commodities, whether it is the raw material, maybe the onion, maybe the potato, maybe the other type of items, other type of food items. We are facing a lot of problems because the wastage in India is too much, and we have to save from this wastage of our crops. So I would like to thank you, sir. You have accepted our request and ready to deliver the talk. We have with us our Honorable Director Shri Bendi Sahab. Sir, would you like to speak 2 words, please?
Yes, Astoji,
Thank you, sir.
uh,
Thank you.
Sri Astoji, Director Legal Metrology, and Professor S.K. Jha Sahab, uh, a reputed scientist from Baba Atomic Research Institute. And today topic is very important things that uh, how to protect the environment from the various type of this facility provided by Atomic Research Institute. So I think that uh, Dr. Jha will enlighten uh, so many things to our consumers and the scientists who are hearing today talk, Jai. And it is great pleasure that he is taking participations in today workshop, Jai. And even though the consumer affairs covers a lot of things, and consumer affairs is having the BIS also, where the standards has been defined, and there is standards for the environment also, with the consultation of Ministry of Forest Department. Uh, I hope that today meeting will be very helpful to all the peoples, and I hope that he will give the lecture that how to preserve the various type of food items, and how to prevent the wastage and other type of things, and apart from that, whatever the maximum utilization of the services of the Baba Atomic Research Institute in various fields. Thank you, Astoji. Thank you, Jasa.
Thank you very much, sir, for your kind and motivated words. Thank you very much for being with us. Thank you, sir. Thank you. Over to you, sir. Professor Jha. Please, sir.
Thank you, Ashutosh for inviting me for this lecture. And moment I received your call, I was in a fixed because the spectrum of the domain in which we work is its range is very high, and perhaps I was in a bit what message I should give to you told researcher are there, some young professors, and also industry will be there. So I will give a bit, because when we do research environment, we are thinking in terms of where we have the because we define environment where no any undesirable change in physical, chemical, and biological component is not a welcome sign. And basically a researcher or a scientist works which balance between the production, utilization of resources, natural material, minerals, and also the environment. So we don't eyes only on the as a common man type. We also want to promote the industries, and basically in this direction whatever we can do we are doing. And since the volume of work is very high, I have just taken a glimpses because as and when Ashutosh Saha will tell me, I will also get more a feeling of the audience, and I will give more new things, and I have made it interesting for those we are well versed, and also for the beginners. I have tried to cover the thing. So basically, man and environment both are closely related, because we are getting everything: air, water, land, flora, fauna, as part of natural environment. and nature provide with us the metals, minerals, and food. Very three important things, and we have to take advantage of these metals, minerals, and also we at the same time food from the same environment, and we have to balance between these three things. And certainly people talks about human activities or anthropogenic activities, which they term it a degradation, but we scientists look in some other ways. Now, since the people talk about the persistence nature of these heavy metals, and historically, mercury, which is linked with Minamata disease, and still the methyl mercury is known as the most toxic uh, metals we have present in the environment. Cadmium is also linked because of Itai disease, which has been because of the cadmium intake from the soil by the rice cultivation. And the lead, because I am from the generation when I join, I have to work on the lead in the environment. And while working on it in 2000, we have first time gasoline was not, the lead has to be added, the percentage started decreasing, and later on we have now gasoline without any lead. Now arsenic also came in a big way to the newspaper and created a sensation because of contaminations. But later on, its complete behavior has been studied, and it is only in a very shallow aquifers and certain conditions they are present. Otherwise, we are not much, and the preventive actions has been taken wherever it is there. So, and but the apart from that, we have the pesticides, hydrocarbon, that is also coming in a big ways. And now we have to think in terms of hazardous chemicals, agrochemicals, and how we can mitigate all these things. And about the gases also, we are newspapers and other places we are seeing. So there are process and development now. These things are maybe not be much of concerns because of the mitigation taken by the industries. Now, before coming to any story, I will be just telling you first about the technique. Then I will come back to the sample collections. Then I will go to the some of the interesting impact studies which we have done using this. And my first part is very much for the young researchers and others, and later parts will be for policymakers. So analytical measurements. So we need to measure, understand the raw ores or minerals, and water is one of the highest intake we are doing. Water is for domestic and industrial applications, and also for domestic and industrial, it is the main 700 liters, not less than 7 every individual is drinking. So highest is the food material. If you see, the water is the highest. And then for characterization of air, again we have to go for, and for the various analytical techniques, and for the management of the environment. So if you see the way we define environment, this has come because of our work and how we defined our business monitoring work. Second. This is basically the monitor we use. The monitoring generally means awareness, but environmental monitoring is something else. It is defined as process activities that characterize and monitor the quality of environment. So environmental monitoring is something else we often use in our talk, but it has a different meaning, and it is now well defined by international community. And particularly we have established now the process and activity. If we are measuring, then only it is called environmental monitoring. And it is a very important part of EIA, and also many times whenever the industries or human activities carry a risk on the harmful effect of environment, we do environmental surveillance. So various type of monitoring we see nowadays in India, Exploratory mining, basically we find out the source ores for the ores we are going. Then we are temporal change in monitoring, what change over the years it has taken, and some interesting example I will show you. And then event or incidental monitoring, suppose some accident happen, then accidents scale is different. Suppose some tsunami comes, the scale is very, you have a fraction of seconds, only 5-10 seconds all the earthquake is there, and you have the tsunami coming, so give you time less. But there are events which you give her time of 4 hours, 5 hours, or 10 years alarm is there. So how this there the monitoring is also important, and the spatial trend monitoring also you see, because India geologically the whole country is different. So if you measure certain things in certain part of the country by geology, other part it may be, one part may be normal, other part may be excess. So that is another challenge we are facing. So basically, we collect the sample from the field. That is the basic, your information will come from there. Then technique you use, analytical data, then quality assurance. And then once analytical data is there, which is used by industry, by commerce, and for the safety. Now, three things is involved in this. Now, basically, for the successful and meaningful analysis, what we required is a representative sample. Your sample should represent the bulk of the material. Then the instrument, what instrument you are going to use should be sensitive enough to measure that particularly object, whatever, maybe metals or maybe some pesticides or maybe some organic pollutants. And good laboratory practice, where I'm going to emphasize this, very important. If you have not a good laboratory practice, very difficult to good results you can produce. Then adequate data processing, how you can communicate that data to translate into some knowledge. So what different techniques are required for different things. Same technique is not same sensitivity. Suppose I have to measure the essential element, then we have different techniques. Like lead, cadmium, you have to measure different technique. Then metal compression varies, and their toxicity is also varies. So the sensitivity and their limits are different. So once the limit is, you should go for a various types. So different analytic, any lab if you go, you will find a number of technique, and these techniques has been based on certain selection criteria. So what are the criteria one should take into the confidence for procuring these analytical instruments? The first criteria is specificity, means you should be specific to that, because mercury cannot be analyzed in one of the instrument, where you have to go for the mercury sensitive instrument, basically cold vapor atomic absorption, which is very important for mercury. Similarly, for arsenic you have to go hydride generator. Then sensitivity, because sensitivity depends upon the instrument's ability to detect. And then speed, how much time it will take to measure the sample. Then cost is another thing. Maintenance cost is one important parameter. Long-term durability is important parameter. Then freedom from the blank is another big issue, because most of the regions contain the contaminants, so we have to see that it is free from it. And freedom from the matrix effect, and which is very important. People ignore this fact that matrix matching is very important. And reproducibility, but once I measure a certain instrument, if I measure n number of times, the value should be within the sigma actually. And multi-elemental character, if I same instrument, if I measure multiple element, it is good. Non-destructive nature, suppose air particulates I have to do, so I have to preserve the sample also. Forensic analysis I have to do, preserve. So there we go for non-destructive technique. All the techniques I have put in the same slide, and basically any lab if you go, spectrochemical methods there, electrochemical techniques are there, chromatography techniques for gaseous things. These are the techniques where the any metals outer electronic environment is very important. But if you go to the techniques like nuclear techniques, where the nucleus property is very important. If any nucleus property is used, and because there the the ionizing radiation, most of them using the electromagnetic radiations, but nuclear technique use ionizing radiations. So where we have neutron activation, instrument neutron, and these are one of the superb technique called reference technique, because there you don't have to any reagent or anything, directly you irradiate and measure the things. So if in India we don't see very large scale production of reference standard or certified reference standard, but there it is mandatory to have one of the nuclear techniques for measuring them. Then surface analytical technique we have, and some are hybrid techniques. Now they are very popular now. GCMS, LCMS, they are coming in a big way. But again, they are cost, if lot of cost and maintenance is involved in this. So any analysis if I have to do in environment, I should have this technique. Now XRF is also technical breakthrough. You can go up to nanogram range. Mass spectrometer is also, and ICP-AES, they are coming in a big way, and because of multi-element character and wide range it has. Another thing is with the nuclear technique, the sample size you required is very. If I have to small milligram of dust, I have to do the chemical characterization of dust to find out the source. Then the best technique is the nuclear technique. After technique, I have a lab, I have full of technique. But the most important is QA/QC. QA/QC is important because unless my product and my procedures should be reliable and efficient, and it should be harmonized with the international acceptability, and international standard acceptance will be there when it is reliable, efficient, harmonized results will be there. Otherwise the other country may not able to take our results. And you have a quality analysis system in the lab itself. So for that there are few parameters which we do, and we provide the solution for this also. The one is the standard individual measurement is the precision, and but the sampling and handling and analysis, there comes a big way, because if you have an error in sampling, then whatever instrument you use, whatever costly, is not going to give you better results, because the basic mistake you have done in sampling, which I will cover in my next slide. Then the bias, and for the bias we are suggesting three things we are practicing in our lab. We spike the samples in the field itself when we collect the samples, or we use standard reference material as a unknown in the field itself. While doing the sample, we just put, because you have handling, storage, transportation, aging. And storage is such a thing that once we were involved in the mercury analysis, we do not know how to store the environmental samples containing mercury, in what type of container I have to do it. And we are started doing the work, and then we could understand what kind of material is suitable and what could be the holding time, because all the elements you cannot hold for time. Some are 48 hours, some are 72 hours, some are 1 week time, but beyond that 15 days maximum. In some of the metals we see that 15 days also can keep the samples, but this is one of the aspects analysts must know before doing any analysis. Now once you have a QA/QC concept is there, now the lab person should minimize this, identify a source of error. He should understand in lab what are the source of error in my lab, and standardized procedure SOP he has to prepare, give it to the technician who is, or the scientist who is working in the lab, and he has to increase the awareness and how documentation should be there. People should read and understand what is the SOP. Effective utilization of resources, whatever resources he has in the lab, how you can analyze effectively. So sometimes happen in the same lab, everybody wants one particular thing or one particular instrument, one particular using that resources he has to effectively distribute among in such a way that there is no overburden in the lab of the material. Otherwise everybody wants to have own domain, own equipment, own places, own fume wood for working, and which is chaos in the lab. Then you have a it is not a once you have implemented QA/QC, it doesn't mean it is a continuous process, and learning, evaluations, new methods, and validation, everything has to be done in a very proper way, systematically way. Continuity should be there. Then there is another terminology which you are doing using is the completeness, means the work, the amount of data obtained from the measurement and the amount you were expecting should be known to us, and the data should be representative. Data should be accurately and precisely represented by any parameters. So generally we mix the traceability in that and just see how it is fitting to that particular samples. Then comparability, because my lab and other labs, if we measure the same metals or same contaminants, and how it compares with each other. Another thing is that quality assurance provide, it give a confidence. When I give my certification of a value, the user have a confidence, or industry have a confidence. Okay, this is my, now this product if goes to outside country, the value will be remain the same, and because I have not done mistake in sampling, I have not mistake in data sample storage, I have not done the mistake everywhere, the check and balance is there. So, and quality control is well in practice, sustainable, because sometimes instrument fluctuations are there. So those factors has not been came here in between. And continuous evaluation. So every year one has to provide in this type of exercises, all the lab, even the person also should be trained doing the quality job with this. Now this graph which we have generated, because we have implemented a software, I will show you the thing. And so we don't take the peak, who is the best, we go for who is the lowest, and the lowest is important in the lab. So lowest person has to be trained, and his capacity building should be there, in which he can go to the top. Now we have staff, good qualified staff, equipment good, management should be very good, and then ideally in charge, who is the lab in charge, he is involved in the planning stage and construction. It should be from the very beginning, because he should know the fire hazard, he should know where the fire exit will be there, what will happen if the electricity goes, and how the cylinders has to keep, where the leakage from any uninterrupted power supply if there, then if some gases is leakage from there, then fire hazard, how we will do. So everything has to plan from very beginning. And whenever we develop our laboratory at various locations in the country, we take care of all these things before the construction of the lab and its operationalization. Now we have a triangle type of diagram which you are seeing. Basically you have the documents, up-to-date training, and the equipment. Once these things are there in the lab, then your systematically approach will be there, and continuous improvement, that is two factor will be there, that is the peak of this triangle. Then you have a quality culture and quality results. So all are linked with this. So without that, if anybody thinks he will generate a quality data and give any industries or any manufacturer, very difficult. This is where the experience and training is very must for the laboratory. Now what we are qualities are required in the lab is the safety, then cleanness, most of the thing, how careful he is, how thoughtful when we are doing, he knows about the matrix, he knows about the reagent which is used, and the self discipline, he has to be disciplined when working in the lab. And many things happen when people do very careless, carelessly in that, and many fire hazard we have seen, particularly those working with the gases. Many researchers have to lost their life because of this indiscipline nature of the work. Now, 6 parameter any laboratory has to control. First is the method. Method has to be checked. Always instrument failure has to be checked. Reagents has to be checked. Standards. Then sample collection and workplace attitude towards the of the analyst. It is very important. Analyst, what is your attitude for the work? If attitude is not good, then whatever you apply, results will be off. Then we have to, you have to, there should be a chart showing the outlines of different lab outline, how the diagram of the room is there, particularly the corridors, boards, classification of work area. This should be well marked. And in case of anything happen, where is the sink, firefighting equipment is where, emergency exit is where, it should be carefully marked. At the entrance of each, name of the responsible person on the door itself, phone number, contact number should be very clearly indicated. Now, apart from that, there are general service in the laboratory. Heating is there, lighting, ventilation, drainage. This drainage, generally we think people doesn't give any importance, and very sophisticated instrument goes underwater, because in rainy days you have a chogging of drainage. Water can seepage will be there in the room, and then you have a issue with the instrument. So you can lose your instrument, such a costly instrument, because of these problems. Then gas is very important thing, electricity and compressed air, vacuum lines, everything has to be looked. If you control and financially permit, out for the give a quality service to for a maintenance, annual maintenance, and then you have the quality of environment of the lab. And there are many things which are do and don'ts in the lab, which should be displayed in the lab. In charge should make every member clear about that. Record of the staff, qualification, training, experience, expertise should be kept. Every member should be trained to waste disposal and lab under this. I have seen waste disposal practices. Lab upkeep has to be very good. The whatever you are using, pipette, burettes, has to go at the same places. And record of daily measurement is very important. Temperature, heat is must, because of fluctuation of the instrument. And the logbook, another important is logbook, where everyday calibration measurements, the traceability standards are available or not, calibration has been done or not, periodically it has to be done and maintained in the logbook. And this should be recorded. Any fluctuation in the peak area or instrument temperature has to be clearly brought out, so that user very much aware of that. And logbooks should be near the equipment. It cannot be kept somewhere in lock and key. It has to be there, so that people can use it. And balance, oven, whenever used, they should be written in the logbook. The safety and good housekeeping is there, and many of the carelessness and foolishness, we have seen the fire hazard in the lab, people are losing in their life. So failures, so they cannot be ignored, but quality of equipment, quality of approach, and the safety is the top priority. So with this, I will now go for another aspect of my briefing, is that about how you will collect the sample. And because if you see environmental matrix, you have a number of samples which we collect in normal days, whereby regulator or by people who are doing research, or by the industry maintaining the trying to understand the health of their industries, or the product, or the export import sample. So water, air, soil, sediment, hazardous waste, effluent, these are the mostly comprised of environmental metrics. And we used to measure the trace elements, anions, or organics. So this is important. And generally the sampling concentration, what we have seen, if you collect a sample soil, you have to homogenize, or anything we have to have. What you do by homogenization, many people do not understand. Basically, we are giving number of units, more number of units you are producing. Once you homogenize, number of unit is increasing. As the number of unit will go up, your sigma value will be lesser, and the error in sampling will be. So homogenization is very, very important factor where you put in a number of unit you increase. And the contamination part, another part is very important, is contamination. It can be done while you are putting in a packet or in a container, transportations or in processing. The contamination chances are very. Biodegradation, another factor is there. Biodegradation of sample, fish sample I am doing, any onion is there or any other product is there, when we are bringing into lab to measure it, they can degrade very fast. So we have to, like meat is there, fish is there, so we have to see how much time, where to keep 4 degrees centigrade in a refrigerator. We have to keep it so that it holding time is more, and you can analyst get time to measure it. Many other like liquids, air, gas. But for the liquid, suppose if you are taking in a mixed zone, then it is okay. Otherwise, if you are taking in natural sources, there are chances of bias, and then you have to homogenize sample you have to collect. So for following any chemical analysis, whatever is sampling is we have done, then separation from interfering elements, then determination by instrument, then data evaluation. These are the 4 important aspects which is doing. Now the sampling, how we perform. Composite sample we calculate, we collect from the self, that is the bulk samples, but bulk samples directly we cannot use in instruments. So we take a small portion of samples, that is the representative fraction, and which is representative fractions. When we take this is termed as the sampling process, and this process we do because we want a representation of the mass bulk which is present in your consignment of the industries or the whatever export import sample you are doing, in which the whole consignment cannot come to the lab. So very small portion fraction we term, that is called sampling. Now there are few important terms, and everybody should be aware of that. Sampling unit. Unit, again I told you that we have to convert the sample in a maximum number of units. So minimum size packet in the consignment of the material. So that is the sampling unit. And increment is a stated amount of material taken from any sampling unit. Whatever we take, that is the increment. And this material, whatever sample, should be representative of the bulk. Subsample is again a smaller sample produced by the subdivision of the gross sample. Analysis or test sample, amount the sample taken for the analysis. Test sample, how much amount you are taking, that is your test samples. Now what is sampling? We define process by which representative fraction is obtained from the bulk material. Bulk is usually inhomogeneous, and most of the cases we have seen. Any soils or tissues or any minerals, if you take, they are bulk samples and they are inhomogeneous. So you have to convert into number of units, and then only you have a homogeneous. Gross samples, again gross sample, bulk sample, lot. That is the gross sample, 1 or 2 increment. If I took number of increments or 5 I taken, 6 I have taken, that is a gross, larger quantity we have taken. And from gross we have to then the particle size distribution come into the picture, and there from that a small portion we take as a sample. Then homogeneity is again degree to which the property or substance uniformly distributed. That distribution is done by homogenization by, again, size, number of size of the particle has to be decreased. As you grow, number of size decrease, more homogenized material will be produced. And sample, a portion of or a lot, is consist of an individual group or individuals. Subsample, again from the sample if you are taken, already explained. So basically my results are there, uncertainty is there. Biased method should, if it is there, then again you have a poor analytical results. Procedure you have done mistake, again data handling, again poor results. Then contaminated reagent, you have uncertainty analysis. So how you control this? So 3 things has to be remembered. First is the blank you control, standards and reference sample. We have effectively seen whenever some reported contaminated area, or sometimes the court tells us to do an independent investigation. So we always use blank, standard and reference samples. And we have seen most of the cases our results and if you do any other places are combined, and our results are taken by the most of the places. Now when you done production, mixture, drying sample, all these things I have already covered it. But what analysts should know, most of the lab, if I go ask, because many laboratory we go regarding our EIA and other work, importance, he doesn't know the importance of sampling. Usko bol diya, he has been told just go and collect the samples. Then statistical background of samples, general method of sampling he should know, type of material, what type method, how he will do, and the proper background is known, because if he has to do some special mapping of the area, how he will do, how many number of units he will convert into the area, those things you have to understand. Proper transmission should be there. Kabhi kabhi many materials, material in which your sample is there will be broken while going. So, and the storage of sample is there may be the pitfall which is there may lead to biasing. Use of analysis, your experience of the analysis, how you are going to look for additional information about it. Try to write down if anything you have seen in that area, any visual things, if anything comes, please write. When you analyze the results, you will able to correlate with those things. So basically there is a famous we are doing overall standard deviation. If you see, it is a combination of two standard deviation, analytical operation and sampling operations. But if your sampling operation is very high, then in that case you will not able to whatever you do, your results are not going to pass the test. So what we have done in BARC, that we have developed a integrated quality management system where you anytime any samples availability, you know, its all history chronology, where it is collected, the person who has collected, taken the GPS reading, photographed it, uploaded in the in this. So that is a part of QC, that person has really reached there, he has collected the samples, his photograph is there, and while putting in the container, he is putting in this software. Then registration of the samples, he give a marking to that sample and a barcode is generated. Then which parameter, now his boss has to see where this sample will, whom to allot. So he will allot XYZ, that will come in the software. And first the preparation, he will allot to somebody for preparation, then goes to person who will work with the instrument. Then analyst will prepare a result and the analysis detail. That detail will be checked by somebody else, and everything in the software will be updated, and the results will be produced in, will be given in the software, which will be checked by the laboratory in charge. And then he will, after validating the results, report generation, he will click the button and the report will be generated. So in this process, you know, if an analyst has done anything wrong, your reagent has been supplied wrongly, or the instrument has fluctuated wrongly, everything known online you can know, because all the records of the years together is available in this software. And since we don't keep it connected with this is a LAN connected, so outside interference is not there. And large volume of sample, we can we have worked for a lot of projects where we have a whole country we have taken to as our sampling. So large of data is stored in this, and will remain whenever person want to check, go back to that sample again, I want to analyze, he can do that very freely. Or this has helped us in improving the quality of our people and quality of the result. Now I am coming in another domain. This is what heavy metal you have seen. There are few things which in our environment, because of the Americans and other France, then you have UK, they have tested lot of weapon test has been done in atmosphere. So the two type of radionuclides seeing in our environment, one is which is by bomb produced, that is cesium and plutonium, which is present everywhere on the earth. So it is not that it is not present, suppose nothing is there, it is not like that. It is just like your naturally occurring radionuclide, this is also present, in which we have the lead-210, polonium and radium. So when I was working, so my job is to how these isotopes have a beauty, because if it has a watch that is called half-life. From the half-life, what you can do, you can understand the many things about the chronology, about the dating. You can do understand when process has happened, which industry, 100 years back what was there, 50 years back what happened, 20 years back what has happened. So those type of signature is accumulated in the sample, and if you analyze correctly with these isotopes, you will understand that. So one example we will see now. Before that, I will go to and tell you about the methods which as a R&D institute we develop a method. Suppose if I have to measure the bomb produced cesium in the water. So what has happened in that case, your minimum detection limit should be such that it should be go to 0.1 millibecker, because this is the level at which the radionuclides are available in seawater or in drinking water. So if I have to go to 0.6 to 0.1, my only parameter variable is volume, because efficiency of detector is fixed and the gamma energy intensity is also fixed. Background, the cosmic contribution is also fixed. So I can't change much of the things. Even I go underground, under bunker, my B is not going to be cosmic. Somehow the background will remain same. Some form or other, somewhere the cosmic if cut up, then building material will there. Then volume has to be changed. Now volume has to increase how much? So you have a tanker, 5,000 liters, 1,000, 5,000 liters of the samples is required. So that was not possible. So, and we have to protect our sea boundary, because seafood safety is also very important for us. Most of our population is dependent. So we have been given a task to develop a technology. So this technology we have developed, and once we develop the cartridge technology, where we have to pass the water through the cartridge, which you are seeing the development process, and we prepare the cartridge here. You see the solutions, we are passing through the cartridge and we are coating with that. And once we coat it, we have deployed and seen that this is successfully working very well. Copper ferrocyanide we have coated here on cartridge A and B, and these are the pre-filters which we are showing here. So basically when we develop, okay, we have developed it, we deployed in C, and then we have seen that you can see this, these two are coated cartridges, and we are passing the seawater. This is the deployment in sea. We used to live in the sea, where large volume 7,000 liters pass through the cartridge. Once it is cartridge bringing out, we are assaying, and then we are counting on the HP detectors. So we can get the cesium-137 peak, which has come from the atmospheric nuclear test. So once we develop it, we wanted to have this advantage, whatever we got it should be internationally recognized. So we have to recognize, so the IAEA, which is BIPM, he is looking for radioactivity part from BIPM. So IAEA approached IAEA. Then IAEA told us that we can recognize if you pass certain test. This is what we have developed for radium, which is one of the tracer. There we have not copper ferrocyanide, we have developed the cartridge by manganese dioxide, and where you can say MnA2 cartridge, they are passed through seawater and it is come. This helps us in finding out the mostly the natural magnetic material deposit on coastal areas. So these are the tracer we need to develop. So we have developed this, and so we have to, this technique has to be participated in a proficiency test. Because to assess the skill of the analyst, so IAEA wants to know if you have developed, how best you are in measuring this. So they have given a sample to us, which is test samples, and what they told, they sent a sample. They told that local water, your sea water, you mix this, then homogenize, pre-concentrate, and analyze the samples and determine the background of your local water. So that was the precondition. They told all the operation has to be under the camera. So you have to videography of all the steps has to be done. So for that, what happened? We have taken the sample, and then we have broken it, put it in the container, and homogenized with 100 liter of water. And before that, the water which we were taking from the sea, that water also we have passed through the cartridge, and we have an understanding how many cesium is there in that water, and that water is considered as a blank, has to be subtracted with this water. So this process we have done, result we have communicated, whole videography we have communicated to IAEA. And what IAEA did, that they have sent it to different lab in the world. It has gone to all the developed country, and since we have developed it, it was more on scrutiny. So there are some 25 labs they have sent the samples, and all the 25 lab were not knowing the value, and they told that you submit your result. So India also submitted, and at that time we submitted for 2 radionuclide, because we are targeting cesium-134. If anything come from the transboundary activities, we can detect very well. And another radionuclide result which we have submitted was cesium-137, and both the occasions our results were near the value 1, actually ratio 1. It should be the IAEA and our value ratio should be 1. So this given up the confidence and acceptability of our technology. Then what happens? C is linked actually. So when we are looking at the data, we are thinking that this radionuclides which is concentrated in Yellow Sea, it could have been migrated toward Indian coast, and it can have a adverse impact upon seafood safety. So once the seafood safety was there, so we have been asked to map the whole country. So what we did, we have mapped the whole country, and you can see here the yellow color, which is there are two different regions you can see. This is Arabian Sea, this is the Bay of Bengal. The Bay of Bengal, actually 10% of the 20% seawater in the Bay of Bengal is coming through the Pacific. So Pacific is containing very high content of radionuclides, so they migrate into this region. So the beyond this, if you see where our Kanyakumari coast and beyond that, the activity is bit higher, and then slowly we are in the blue zone where the activity is, in spite of the fact that most of our nuclear installations are there, there is no trace of activity in our coastal area, and our seafood is free for safety. And then another thing what I will tell you are new how to use these radionuclides for a healthy working of our industries or healthy environment, because these radionuclide, as I told that suppose lead 210 which is naturally occurring, if I measure this, this will give history of 150 years. If I thorium 238 if I measure, then this will months to years. Beryllium weeks time, and carbon 14 will go up to 20,000 years. So these are the dating time is age watch is involved with these radionuclide, and we can very well understand if something, because any industry needs water, and it has to release certain effluents, and people make hue and cry. So we can just demonstrate them if anything really goes bad or you are getting the same environments. So we have been asked to do this work. And another thing is that once the food is, again, how the food is good or bad, and how the bioaccumulation is taking place from the lower trophic, the benthic organisms to your fish, which is the main intake path for the human being. So for that, what we have done, this slide I will take a bit time for this explaining you, because here what will happen, the radon in uranium series, if you see the radium decays to radon gas, and this gas escapes to the environment. Once this gas escapes to the environment, it decays by 3.2 days, and once it decays, it comes to polonium and lead. Lead is a particle active, and it comes and deposit on the surface of any water bodies, and slowly with the particles it will be a part of sediments. And once it is the part of the sediment, so there we have a two. Once the radon which has escaped and which has come by atmospheric process and deposited, another radon is which is not escaped and which is in the equilibrium with the radium 227, which is the parent of this. So there are two lead we are getting, one is supported, one is unsupported. Now the unsupported part, the supported part will be okay, it will decay with your parent if they are in equilibrium, but unsupported part will decay with its half life, which is 20 years. So 21 years, sorry, 21 years. So it will decay with that, and 5 half-life you can measure. So we can go very well go up to 100, 150 years. So what we have done, this is the area, Thane Creek, and particularly in the Thane Creek, we have a number of industries. There are something like 1600 industries in the Thane Belapur industry, and most of them are chemical based industries. And in this is the Bombay Harbor Bay, and where all the industries their even water need and also effluent release are taking place. So multiple source, land based source is existing, and we have asked to resolve it, and resolution should be there about the health and status of this, because again, because of this is a creek, again the fish productivity is very high, so we are more bothered about the safety of the seafood. So we have been asked, and since these are land-based pollutants, we were nothing. We are not knowing what kind of environment was existing 100 years back and what is environment today. So what first of all what we did, by measuring this lead to 10, we have found out the sediment by rate at which this water body filled with the sediment. With that understanding, which we done with the access lead to 10 and depth, both we have measured access lead to 10 and depth. So we have seen a sedimentation rate of 0.7 centimeter per year. Once we know this, then we collected a core. Apart from that, you can see here a picture here. This was published in a Journal of Radioactivity when we got this signal. Any core if you collect and measure, you will get the peak. Latest peak will be a Chinese test in 1973. Then if you see 1963, this is the US and UK test, atmospheric test, and French test has been done. 73 also French test has been were there. Then 1959, again the massive atmospheric testing done. 45 was the year when this man-made radionuclide came into the atmosphere. So with resolution of these peaks, we calculated the sedimentation rate. When the rate is known, we understand how the chronology and what is the age of particular layer of the sediment. So here, this is again the Thane Creek. We understand the sediment at different locations. So we converted into zone, different zone, and we try to see if anything drastically change. There are locations where nothing is there, no change. Whatever in that zone, if you allegation you put, there was no change was observed. So we can out of 1600 industries, we can 500 industries, we can just tell ki yes, they are of no intention is required. Their plant is running very good, product is also good, no nothing has to be done. And then another 5 or 10 plants we can see if something goes wrong with the plants. So this when we put these results in the journal, the industry itself came, and they were happy. At least we could tell, because they correlate with their plant maintenance when something has gone wrong. So they were very happy ki at least we could capture and tell them, and so they will have a precautionary measure and they could understand. So very famous was the nickel, and nickel we can one of the industry which was having a problem with the nickel, we could tell them which are the occasion when the plant health has gone bad, and they could see in the records. So we have validated this method, and particularly this work we have made it very clear that our Mumbai Harbor Bay no such issue is there. Another is earlier our the alkali, most of the some of the plant were using the mercury as a their electrodes, where we have been advised them seeing this peak actually we have advised, so they have changed their process, and some healthy transformation has been happen, which helped the industry to grow. Then another thing we are interested, particularly the oil refineries where the rare earth is was considered those time very, yeah, but nowadays these all rare earth are very precious metal and precious for us, and we all need this for our use. So we have just tried to see if in the past our industrial, when the industrialization was happened, if anything is accumulated, or is it really we can pay some attention towards this. And some of them we can very well say cerium, only cerium we can see here higher in 70s 80s, because it is used as a catalyst in most of the refineries in those times, and then its concentration has gone down. Similarly, in the middle rare earth, if you see, we have only seen in terms of ytterbium a bit increase, other are not of same as their crystal origin, and they remain the sediments. So not much was seen in those directions. Apart from that, another work where the nuclear technique very well give, whether the other techniques will not able to do. And when we publish our work at that time, because I was involved in technical cooperation, our UNDP has given the project, and where India was asked to lead the project. So I was the lead country coordinator for this project, and particularly this particular area which was impacted by tsunami, and the impact time was very less, and whatever happened to the environment, it happens in very minimum time, and time was not given much. And I have to I was seeing in another way, because these are the source of minerals for us, and most of these are rare earth minerals are coming from this area. And more worried as the Department of Atomic point of view, what happened to those minerals. So I have taken the this as a tracer radium, which is naturally occurring, and when I measure it in a core and particular location in the cellular, we have seen there are many places the ratio between thorium and uranium, like Gulf of Mannar. The initial before the tsunami, the concentration was around 2.5, ratio was 2.5. After the tsunami, the ratio has gone up. So similarly, the Pichavaram, one was the area where the mangroves are there. Again, we have seen the decrease, the ratio was decreases. And some of the areas we don't have any comparison, but 3 area we have compared values, where before the tsunami we have measured in our surveillance program. And another thing is that the column, there is an area where we have a lot of deposits of rare earth is there. So in the column, what we have done, we have taken a core which was around 50 to 60 meter, and we have measured the thorium uranium concentration. So what we have, surprisingly, this if we 10 centimeter on the top of the surface, if I take, because you, if you area you have visited, there are sand dunes are there, and on the surface if you see they are called high background area, because of thorium content is very high. To our surprise, after tsunami, the thorium content was very less. So so something has happened because of tsunami. So this 40 centimeter, up to 40 centimeter, the deposit was churning was there, the lot of churning, and a number of publication went there. But from this graph, we also published our work, and we have intimated at that time that there is a depletion in the mineral resources because of tsunami. But most of the researchers, 99% were telling it will enrich, but my data was not showing is enrich. So what I have observed there, this is the water table. You can see the particles. This is a picture I have just demonstrated to understand my process, what has happened. And if the tsunami comes, these are the contaminants. When tsunami comes, the particles have gone up, the smaller particles, because the most of the content try to have a less than 63 micron size. So we have a silt, sand, and the particulates. So these particulates, which is less than 63, which we define, because of wave, it has gone with the wave up, left the surface, and then it whole this plume has moved in whole the plume has gone, so washed away. Some washing has been taken because of this physical process of the tsunami wave. And in this process, we are the first to report some depletion will say, and that depletion will emerge after few years of time, because nature had its own way to give the signal. But we have intimated long back, and now we can but the restoration will also be there. It is not a negative side. Again, the restoration will be there. That also we have projected. Now what we have done, we have seen that most of the signature of natural elements has changed there. So in the pre-tsunami and post-tsunami, pre-tsunami, see, one indication comes of how these minerals have evolved. So one, lead. If you see in post-tsunami, lead has gone down. But if you see before tsunami, the concentration was very high. Such a high concentration coming to such a low concentration of these metals clearly indicates some depletion has taken there. And that was the work which we have done on coastal marine environment after tsunami impact. Another thing which we have done after Fukushima, we were worried if anything comes in our environment, how long it will remain in the environment, and whether how much it will remain, and what will the life of that if such thing happens in our places. So most of the people, Indian Ocean, they have reported a half-life of for a particular radionuclides 20 years, or cesium-137. Atlantic Ocean 22 years, Pacific 15, and the whole world, if we take, the IAEA reported 28 years. But when we went to our coastal area, because highly productive, and so what will happen, fate of this? So we have measured the same location data. It has been recorded in 63, 64. Those records were available as a, we started measuring in 98, 2000, 2014, and then we have because a long-term data, and basically we have seen the how the activity concentration decreases. From this, we have calculated Indian coastal region, it is only 13 years, and which is a very, very short life, because of large silt content our coastal area contain, or most of the rivers which contain the silts, and they grab the cesium from the water and deplete it from the water. So depletion rate is very high, and we are confident, and for any such process which, and it has been accepted by the international community worldwide. Now coming back to, now we are coming to summary on the cesium-137. So because our coastal areas, if you see in most of the places, high productivity, and fish is eating population is very high. They depends on protein on fish, and the fishermen, they depends upon selling the fish. So we wanted to understand from the range of radioactivity C is containing 13.7 becquerel per liter of activity. From that 13, so it is natural. Most of them is potassium. K40 is the highest activity which seawater contains. But we were interested to know about anthropogenic, how much it is there. So when we measure around with other countries together, Asian region, fish was showing from the 0.02 to 2.76 becquerel per kg weight. Mollusk has shown 0.01 to 1.84 becquerel per kg weight, and crustaceans, which are the lower trophic level, again up to 1.5 becquerel, and arithmetic mean of all the range we have taken is 0.5 becquerel per kg, which is near the detection limit. So our marine fish production, the people who is doing the fish, and our now Blue Revolution is also one of the policies. So our fish seawater is free from any contaminations, at least from the radiological point of view. So this is again, I have grouped in another group, and just given the range and mean values of all our fishes, which is particularly in this region, because it is export, import, everything is doing in the coastal area. So we normally have measured. So any comes through certifications, we understand the range is coming in this, and they are it is considered existing exposure situation. So it is just like our natural values only. So another thing is that I have a scientist, I have measured it, I have a lot of information, and there was many hue and cry by the fishermen community in Kanyakumari. If you see in the Google, you will see many agitations has been done in Kanyakumari about this, about their safety and the economic value of their fish product. So it is our duty to information should reach the user community or the community which is more fearful about that. So we have been gone. Normally we interact the fishermen community, and we tell the advantage on the climate change, seafood safety, and fishermen. So we have a meeting with the with media to the fishermen community. We also meet. So one of the meeting, media people were also involved with us, and local fishermen. All the questions, whatever misconceptions about the role of industrial nuclear energy program for environmental protection at Kanyakumari, we have briefed them, and the whole agitations, and we have shown them the facts and with the figures, and we try to pacify them, and tell them that your the market value or economic value of your fish is not going to come down. With that assurance, the fishermen will feel very happy, and at least the fear which is given to them, that our export value, because most of the fishermen in Kanyakumari, they export the samples to the neighboring countries, and so they any 1 rupees less value, economic value, also is a great concern to the overall production, because few hundreds of tons if production is there, and if their productivity can come down, because many countries spread the rumors also. So in that case, we have to take the protection of our own people, our own occupations, and particularly the economic value of the product is very, very important. So this work also we are doing. We are publishing in literatures. Most of the literature are open source, and it is high time that our whatever method we have developed, whatever the process we follow in the lab should be available for the common people, common lab, so that in a country like India, we need hundreds of such labs, laboratory we require, trained people we required, if our export has to go up, and our food safety has to, particularly in terms of contaminations, and many undue societal fear has to go. So in this process, I think the work which is done by Ashutosh ji is remarkable, and particularly it will go a long way. We publish bulletins also, like seafood safety, radio ecology, one bulletin we have published. Online it is available. In case there is an organization, so this radio ecology, one can read this various things which we have developed and indicated. All this are there. There are few international experts which are also contributed in this bulletin. Then apart from that, another thing I would like to tell that I was working also in not only in the mainlands, we are also working Northeast Hill University in Shillong, and particularly though tribal communities are very much fearful about their existence, because very small community, and their societal structure is different, and any outsiders they feel in a different way. So we given the confidence, we done the survey in Meghalaya, and this is the first book which I have published, how to for EIE, how to generate the data required for EIE studies. And this book I have published in 2002, but the only book published on this particular topic, and it covers everything, how one will go. Whatever I have given you the today is summarize all the detail in this book, and this we have distributed to most of the trust, and at that time those NGOs were existing in Northeast, we have given, because we want public to not to panic, and particularly regarding the safety of their health, their kids, and their old people, and I am somehow we have successful in restoring the confidence of people, and bring them to more like more like us only. And those time it was very difficult situation. I worked from 1998 to 2000 in those areas, and particularly mapped whole the areas. But regarding the environment, I am not touching today. Today I have given the talk which was relevant for today discussion. So with this, I will thank again the Legal Metrology Department, Agarwal Sahab, for giving me a chance. And time was such a short notice, and the spectrum is so high for me. I was not able to understand from where I should start and where to finish it. But I have tried to cover most of the. Anybody wants to more go in fundamental details about the construction, about analysis, about the contaminations, about if any allegations are there on the industries, we are always there to support them. Thank you very much.
Thank you very much, sir. Thank you for your kind and very impressive and the important information which you have shared with us. I would like to request you to kindly unshare your presentation, please. And sir, share this presentation with me on WhatsApp or the mail so that I can share with the participants, and we can put this whole presentation on our website with this video, with your kind permission.
Yes, sir. It is there. Nothing is in this. All are in public domain. I will share you.
Thank you.
Only thing is, I am very poor in. 1 second, sir. Let me close my presentation. Sir, I will share. It is only you have to download with my Google Drive because this is 50 MB slide is there. Which email is refusing because I was trying to send you, but there was refusing from the Yahoo Mail to take this very big size. So I will give my Google Drive link, sir.
Please, sir. So what I will do, I will share your presentation as well as this complete video in the public domain on our social media platforms as well as on our website, so that the people can see at any point of time and can get the information and the knowledge wherever possible with your kind permission.
Yes, sir.
Thank you very much, sir. Now the platform is open. If anybody wish to ask any of the question related with the topic, he is free to ask. Anyone who wish to ask any question? Otherwise, with this, I would like to thank all the participants who are present here. Next week with the next topic, which is very important, and we are having the next, because in India now we have more than one accreditation body available in India. NABL, which is actually the mother of all these standards which brought in India. After this, we have FDAS of Dr. D.S. Tiwari sahab, and QAI of Mr. B.S. Rana. Then one another body